Okay, so how do we combine all of the concepts that we've just learned today together? Okay, well here I have a circle which has a radius of 5, and I have a hexagon which has a which has um, a length of 6. And if I asked you what the perimeter of the hexagon would be, you'd probably tell me that it's 6 times 6 is 36. And you'd be correct because if you add up all the sides, you get the perimeter. 6 times 6 is 36. However, if I asked you what the area was, if I asked you what the area was, you'd probably have a little difficulty with that. The first thing you would probably do is check your reference sheet, and then you'd be disappointed to find out that there's no formula for the area of a hexagon, right? So what do you do there? What do you do in that circumstance? Well, they will never ask you a question like that directly unless they give you enough information to solve it. So let's see what's one of the ways that we can approach a question like that, right? Well, you're also, before we discuss that, you're also going to notice that I have two words here. I have the word inscribed and I have the word circumscribed written at the top of the screen. When something is inscribed, it's pretty much in the image. And when something is circumscribed, it's usually circular, or it's around the image. Circum means circular, so it's going to be around the image. So here, if I take my circle and I combine it with my hexagon, we can see that the hexagon is inscribed. The hexagon is inscribed in the circle. And we can see that the circle is circumscribed about the hexagon, or circumscribed around the hexagon. Okay? So, what's the benefit of doing a problem like this? And what's a question that you might typically see? Well, first, they might ask you a question like this. They might say, what is the area of the shaded region there? And you might say to yourself, well, one thing I know for sure is I can figure out what the area of the circle is, right? I can figure out what the area of the circle is. I know how to figure out the area of the circle. That's pretty easy to do because I know that the formula for the area of a circle is pi times r squared, which is going to be equal to pi times the radius squared, which is 5 squared, which is pi times 25, which is about 78.5. So I know the area of the whole circle is 78.5. But then, they're not asking me for the area of the whole circle, are they? They're asking me for the area of the whole circle minus the area of the hexagon. And again, do I know how to find the area of a hexagon? Not yet. Not yet. So how do I find the area of this shaded region here? Well, let me ask you a question. Once you find the area of a hexagon, what are you going to do? Are you going to add that to this number, or are you going to subtract it from this number here? Are you going to add it to this number, or are you going to subtract it? If you said subtract it, you guessed correctly. Yeah, you're going to subtract it from this number, okay? So now let's take a look here. Let's see, how do we find the area of a hexagon? Well, first thing I want you to notice is that, notice the radius here. Notice the radius of my circle. We can say that it's 5, right? Now I want you to notice that the radius goes from the center of both images to the edge of the circumference of the circle, right? It also goes to the edge of the vertex of the polygon, right? But then what I'm going to do here is, and by the way, if you notice that this is this 5 here is like almost creating a triangle, that's a good observation. Because then what I could also do is, I could also draw another side like this here, right? Going from the center to the circumference of the circle. And that would be another radius, right? And if this radius is 5, then this radius is also going to be what? It's also going to be 5. It's also going to be 5. So now what I have here is I have a triangle. I can find the area of a triangle, right? How can I do that? Well, in order to find the area of a triangle, what do we need? What's the formula for the area of a triangle? Area is equal to 1/2 base times the height. Well, I got the base for sure, but what are we missing? We are missing the height. Well, that's where this comes in. This is where I go in and I put in my own height, right? Straight down the middle, and it's going to be perpendicular to the base. right? Now here's one thing you need to notice. Look at the radius. The radius goes from the center of the image all the way to the circumference, right? Does this height do the same thing? Does this length go all the way from the center to the circumference? No, it doesn't. It's kind of it falls short. Notice how it doesn't touch the circumference, right? It doesn't touch it. It's missing this little spot right here, right? Well, this height in a polygon, that in a triangle, in a polygon, is called an apothem. Okay? It's called an apothem. Just so that you don't confuse it with a radius, okay? Because the radius goes from the center all the way to the edge. This only goes to the base of the polygon, okay? That's called an apothem right there. Remember that. It's important. It's going to come up later on. So now that I have my height or my apothem, now I can, by the way, if this is going down the middle and the base is 6, this side is what? This side is 3, and this side is 3, right? I know that this is 5, right? How can I find this height here? What can I use to find this height? Well, we can use the Pythagorean Theorem, right? I know that this is A, this is probably B, and this is just C. So I can say A squared plus B squared is equal to C squared. And if you did the Pythagorean Theorem, you would find out that this side here, by the way, what are the magic numbers for the Pythagorean Theorem? They're 3, 4, and 5. So this height right here is 4. This height is 4. If you do the Pythagorean Theorem, you'll find out that this height is 4. Well, now that I know this is 4, by using the Pythagorean Theorem, now I can find the area of this triangle. Well, the area of a triangle is half the base times the height, right? If the height is 4 and my base is 6, well, it's half the base times the height. Half 6 times 4. Well, half of 6 is 3, and 3 times 4 is 12. So the area of this triangle right here is going to be 12. So this is 12. And now, how many other triangles do I have? Yeah, I have 5 more. I have a total of what? Of 6 triangles, with all of them that are all going to have areas of what? Areas of 12. So that's 12, 1, 2, 3, 4, 5, and 6. And 12 times 6 is 72. So the area of the hexagon is 72 units squared. So then I can say 78.5 minus 72 is going to give me 6.5. So the area of this shaded region here in yellow is 6.5 units squared. Okay? So let's recap. How do I find the area of a hexagon? Well, the first thing I got to do is I got to take my triangle. I got to create a triangle, right? I got to create a triangle, create an apothem, use the Pythagorean Theorem to find the height. Once I find the height of the Pythagorean Theorem, then find the area and multiply that area times all of the triangles inside the polygon. We could even do the same thing for this here. Let's say for example that this pentagon has a let's say it has a base of, let's say, 7, and let's say we say that this side of the triangle here is 8. Okay, well, let's not make it 8. Let's make it 10. Let's make it 10. Okay, so this won't be the answer anymore. Let's make it 10. Can we find the area of the entire pentagon? Let's see if you can figure that out. I want you guys right now, the first thing I want you to do is I want you to find the height of this triangle, and then after you find the height of this triangle, find the area of this triangle, and then find the area of the pentagon. And let's see what we get. Let's get to work, guys.